Welcome to another video at Tech. I was always interested about Tesla power coil. Finally, I got the opportunity to take one in my hand. I bought this DIY Tesla coil kit from eBay just under £5. It is pretty much simple in terms of assembly. Now, for understanding how it works require significant study, and if you search online you see Tesla coil is the nature of it is very open sourced, and there are basic to very advanced level. Now people get Tesla coil mostly for the aesthetics, that it looks very cool, but if you try to understand how it works and want to develop one yourself, then it requires some study and understanding how all the power and voltage conversion happens. In this video, I will mainly use it as an opportunity for myself to learn about the Tesla coil, just to get familiarized with the components, also do some basic soldering practice, then also review that the quality of the arc. That is what many people is concerned about. It looks really cool, isn't it? But we see how much arc we will generate, but verily it is a very cheap kit, and it is a great opportunity for anyone to learn about basic electronics, MOSFETs, IGBT and other transistors. Now this Tesla coil comes with an instruction. Unfortunately, it's all written in Chinese. However, you can see the components number and the English name. From there you can figure it out. But the circuit board itself is very explanatory. As you can see, everything is oil marked, and the components, there are only few. You can't go wrong, and there are plenty of materials online. One of the main component of this circuit is this Fx-951 MOSFET. It is a switching device. Basically, when you apply some voltage on the two side pins, unless until the voltage is applied at the middle pin, the current will not go through. So this is established the switching by applying the voltage to the middle pin. The second component I would like to talk is TIP41C. Here I am educating myself. I'm just reading from online. So basically it has got 3 pin, same like the previous MOSFET. So the 3 pin, one is emitter, base and collector. Base is the middle pin. Unless until you apply some current in the middle pin, the base and collector will not be short circuited. They will not let the voltage to pass through. This transistor is used for mainly for audio amplification. That's what I think for this circuit. Now this is 12 volt power socket, DC power socket, and 3.5mm audio jack socket. 1 microfarad dielectric capacitor. It has the polarity, so the longer leg is the plus polarity and the shorter leg is the minus polarity. This is important when you solder this circuit on the circuit board. The fluorescent lamp comes as a testing device. It is not soldered on the circuit board. This is again another very important part for this circuit. This is called secondary coil. 105, which is 1 microfarad multi-layer ceramic capacitor. I will be using my Hakko Fx-951 soldering station. I will be using 0.7mm 40-50 solder cable, and I have got the bigger diameter solder cable as well, just to help, because those big pin with the audio jack, it requires a lot more solder. And the flux paste, I will be using MG chemical flux paste, and this is the heat sink. You can see the heatsink is basically the MOSFET, and the transistor get really hot during the operation, so this dissipate the heat. This is a good board for solder practice. As you can see, I just put the transistor in, and then you bend the part so that it just don't fall when you bend it over. Then slowly you connect your solder iron head, And when you connect the solder iron head with the component, make sure you just keep it for 2 seconds. Within this 2 seconds you need to get your job done. So when you first touch it, then you make the component hot, component pin hot as well, and then you nail the solder on that place, and you make sure the solder is distributed equally. Then you let the solder iron get away, and the liquid solder gets solidified, and it gets slight concave shape. Now all of my soldering is almost complete. It's just the time to do some final touch. I'm not a pro, by no way I should not claim to be a pro. I am a beginner, a newbie in this business myself. Here you can see the secondary coil. So this secondary coil, it's not the primary coil. The secondary coil will, now I'll put some glue in it and fix it, and the other tip will go under as a ground. Now is the time to connect my primary coil. Coil is the coil which will actually be connected with the whole circuit. This shiny coil is the secondary one. Secondary coil has no physical connection with the circuit except the ground. So the primary coil, as you can see, I am connecting now the thick gauge coil. It will be carrying 12 volt DC charge. That because it is spiraling like a snake, it will induce magnetic flux. That magnetic flux in terms will affect the secondary coil, the shiny coil, and it will be becoming a transformer almost, and AC charge will be induced. Thus that AC charge will be almost like broadcasting on the air, and the voltage will happen. So it is called Slayer exciter circuit, and Electroboom has talked a lot about this. I'm a big fan of Electroboom. If you are interested, you can check his video. Now let's put all the spacer in and make the circuit stable. The problem is I did not have any 12 volt socket, the one it is with this circuit, so I have to solder it under. As you can see, I just soldered it under, and just the ground and the positive voltage. Surely my Tesla coil circuit is working here, but it's a bit disappointing that there is not much. There is arc, but it's not a big arc that you can see. I'm struggling to show it. I saw the arc, but it's so tiny that even the camera pixel can't identify it. I'll be investigating more that is there a better way to make it more efficient, and I'm also buying more parts from Farnell, that exploring how can I make one myself and make it more efficient. As you can see here, you can see the tiny arc. Thanks for watching all this, and I will see you at next time. Thank you very much.